I'll draw it, then I'll show you. Again, my convention, right hand side is cathode. Okay, so cathode, you know, it is patterns go, so it is negative. So it is negative. This is good. This is negative. This is good. This is negative, and this is okay, and is being connected to battery. So this is called connected in series. Okay. Now say here you have taken copper circuit. Here you have taken zinc circuit. Here you have taken lead nitrate. Okay. So when I pass same quantity electric because it is connected in series. Okay. Then in that case, all the metal ions which are deposited on the anode, you will find they are proportional to their chemical equivalent. equivalents. All right. So it can be a ratio. So I can write down here weight of, instead of writing like this, I'll write it in short form. I'll write here now W CO CU by W Z is equivalent to the chemical equivalent of Cu chemical equivalent to Z. Okay. Then if I compare this and this, it will be W zinc by WAG is equal to chemical equivalent of zinc and chemical equivalent to silver. Now, if I compare this and this is connected in series now, then I can write that WCU by WAG is equal to chemical equivalent of Cu and chemical equivalent of AG. So this is called Faraday's law. When same quantity of electricity is passed through different electrolytic solutions connected in series, they are connected in series. So sorry, this is connected in series. The weight of different substances liberated, we have taken only this now, liberated at the electrodes are directly proportional to their chemical. The numerical you have written though.
Yes, sir.
Okay. Now see, here you have to find two things. One, you have to find out the amount of copper deposited, and also you have to find out the amount of electricity passed. See here. Here, these are the two beakers now. Here you have gold salt, and here you have copper salt. Okay. Okay. Now, this is the one. So this. So what we will write now here? You are being asked to find out amount of copper deposit, and this is good. So this is cathode. This is M. Okay. Now we know that weight of gold divided by weight of copper is the chemical equivalent of gold divided by chemical equivalent of copper. So I can write opposite way also. I can write down here like this: WCU by WAU by chemical equivalent of Cu and chemical equivalent of. This is being given. How much it is? 9.85. I have already taught you on Thursday how to calculate chemical equivalent. See, chemical equivalent is nothing of an element of chemical equivalent of an element is equal to atomic mass of the element divided by what? The charge on the. So see, copper sulfate. Copper sulfate, what is the charge? When copper sulfate breaks down, what you get here? Copper sulfate breaks down to give you Cu2 plus and SO4. They have already mentioned the charge of gold is +3. Okay. So let me calculate now. Chemical equivalent of copper. So atomic mass of copper is how much? 63.5. Charge is 2. And chemical equivalent of gold, atomic mass is 197 divided by 3. Find out. Fine. Then after that, from there you do. This is the chemical equivalent. Find out. Gold is already given 9 point something. Fine. What is the first step? Z into I into T. So you know the weight of copper, or you can take anyone. You can take the copper or you can take gold. Then calculate the Z. Z, I told you what is Z. Z is equal to what? Z is equal to chemical equivalent divided by 96,500. You know how to calculate chemical equivalent. Okay. So therefore, W is equal to what? Chemical equivalent divided by 96,500 into I into T. Now find out this I. Fine. Don't sleep. Zero point 0.804 ampere. Hello?
0.804.
Correct. Let others also do. Second part. Galvanic cell or voltaic cell or electrochemical cell. Devices in which energy is produced from spontaneous devices in which electric energy is produced from spontaneous redox reaction. Are called electrochemical cell. Actually, this electrochemical, the word is being used in your book, but we call it galvanic cell or voltaic or cell or or voltaic cells. See, electrolytic cell is made in one beaker or one container. But voltaic cell or electrochemical cell is made in two beakers. Okay, so by convention it is cathode. And here it is anode. But very interestingly, here cathode is, it is not a negative electrode, it is a positive electrode. This is called salt bridge. This is voltmeter, not ammeter. Here in this galvanic cell, this anode is made of zinc, and here it is made of copper. And it contains a solution of zinc sulfate. There it is 1 molar. And it contains a solution of copper sulfate, and it is 1 molar. And it produces a voltage of 1.1 volt. Cathodic half cell. This is called anodic half cell. This is also known as oxidation half cell, and this is called reduction cell. How galvanic? Galvanic cells consist of two containers where metal electrodes are dipped in the solution of the salts of same metal. See here, zinc is dipped in zinc sulfate, copper is dipped in copper sulfate. The cell are internally connected by a salt bridge and externally connected by metal wire having a voltmeter. We'll see the cell. Cell reaction. Okay. Now we'll do in anodic cell. What happens in anodic cell? See, this zinc rod is there. From there, zinc loses electron. Okay, so I'm supposed to write here 2e. Don't write. Then you get here zinc 2 plus. See this solid. But in a chemical reaction, we are not supposed to write anything with negative sign. So what we do? We transfer it to this side. When you transfer to this side, negative become positive. So in that case, the equation is written like this. Plus. So when it loses 2 electron, what is happening? Loss of electron is oxidation. Because of that, we call it oxidation. I'll tell you why we call it half cell. Then cathodic cell. See here. So the zinc, what will happen? The zinc is from the rod zinc who is going to lose electron on the surface of the electron. So this electron will be here. See, the electron will be here now. And this electron now will travel in this direction. Okay, it will travel in this direction and it will come here. When it comes here, what will happen? The copper ion is there, copper ion. The copper ion is going to take the electron and it will become copper solid. So what you are going to observe? Gradually you will find the zinc rod, the thickness of the zinc rod is decreasing. And here, as the copper is depositing, the thickness of this copper electrode is increasing. So gain of electron is what? Reduction. Now see here. I add it. This is the overall reaction. So this electron and this electron get cancelled. So what should I write now here? Zinc S copper 2 plus aqueous. See now. So this is a single reaction. This single reaction is made by two reactions. Because of that, we call it oxidation half reaction, and this is we call it reduction half reaction. Okay. So this is because of that we call it oxidation half cell, and we call it reduction half cell. Wait. Now see what is going to happen. See here. Let me write here. Zinc sulfate. When it undergoes dissociation, you have now zinc and you have got sulfate. See, this is +2 and this is -2. It is for each zinc, one sulfate is there. Salts are always electrically neutral. Now, what is happening here? In this case, we find that gradually this zinc is going into solution and the 2 electrons. So the number of the zinc ion is increasing. It cannot be like this. All solutions are electrically neutral. Now in this copper sulfate, what is going to happen now? Here in this anodic cell. Now in cathodic cell, what is happening now? See here, copper sulfate. It breaks to give you copper 2 plus ion, and you are getting sulfate. So it is 1:1. But what is happening now? See now here, this copper ion is taking electron and becoming copper. So in this case, zinc ion is increasing. In this case, copper ion is decreasing. So here the solution is become positively charged, and here the solution is becoming negatively charged because nothing is happening with sulfate. So it is a peculiar situation. Cell is going to stop. So we have to make it neutral. That is being done by salt. Okay. So please write down this equation. Okay. And please write down. Now how to make it neutral, I'll tell you. How to now neutralize this excess zinc and how to neutralize this excess sulfate. So we'll see. So let us first write what is salt bridge. It is an inverted U tube containing a thick paste of either electrolyte such as potassium chloride, potassium nitrate, ammonium chloride, etc. Thick paste is not electrolyte in gelatin or is a type of soil. We call it agar agar. After writing, then you write, then I tell you the purpose. Let me write, suppose it is having potassium chloride. Right here now, KCl. So in your diagram, you write KCl.
Sir.
Okay. Now, functions of salt bridge. Before that, I like to tell you. See here. First of all, salt bridge being used to complete the circuit. This solution is being connected to this solution. If the circuit is not complete, electrons will not flow. Second, see here. When in this case zinc ion is increasing, how to neutralize the excess zinc from there? The chloride, because chloride dissociates as K plus and Cl minus. Then Cl for each chloride is zinc. See here. From KCl bridge to give you K plus and Cl minus. From there, for each zinc, 2 chloride comes here. Then 2 chloride neutralizes the chloride is 2 minus. 2 chloride, each chloride is minus. 2 chloride means 2 minus. It neutralizes the excess zinc. Now in this case, what happened? Copper ion is being converted to solid copper. So sulfate is extra. So for charge of potassium is 1 positive. So 2 potassium comes and neutralizes this. So it maintains the electrical neutrality of the cells. Okay. Now functions of salt. It completes the circuit by joining both the half cells. Second, it maintains the electrical neutrality of both the half cells. Whatever the galvanic cell that I have drawn, along with the zinc sulfide 1 molar and copper sulfide 1 molar, this galvanic cell produces a potential difference or of 1.1 volt, or produces 1.1 volt of electricity. Produces 1.1 volt. Electrons are generated here. Electron migrate in this way. Electrons move from anode to cathode, but electricity moves from cathode to anode. Steve is very strange. Why? This is again by convention. Because it's positive. We always feel from positive only the thing will come to negative. So electrons flow from anode to cathode, but we say electricity moves from cathode to anode. So don't get confused because it is positive and this is. Now why do you call it negative? Because in electrolytic cell we have found cathode we say negative and anode we say positive. But look by your own eyes there. Electrons are negative charge. Where the electrons are accumulated? Electrons are accumulated on this electrode. So this electrode gets negatively charged. Because of that, it is negative electrode. And it migrates to the copper where no electrons are produced. So we call it positive electron. This is a basic difference between electrolytic cell and electrochemical cell. Now I'm coming to a very important portion. So, but in that case, what you have to do? You again have to draw this one. Please draw the whole thing again. Okay, and when you draw the whole thing, in original diagram, please write this two. This two you write. First you write, then again you have to draw the whole thing. Right, first write, after writing you tell me. Then I'll draw the second diagram.
Done, sir.
Okay. Now please draw the same thing again. Same thing. Again you draw. This is external circuit and this is internal circuit. This is resistance. This instrument is called resistor. Okay. Now, in this case, electricity will move in this direction, and in this case, electricity will move in opposite direction. Draw.
Done, sir.
Okay, now see here, very interesting. See, this external circuit means what? It is being connected to a battery. Here, this is producing electricity, and this we connected to a battery, and in opposite direction. See, it is positive, and this is negative. And this opposite means what? Negative end of the battery will be connected here. Will be connected here, and the positive end of the battery will be connected. So, see, now with the help of rheostat or resistance, we can control the flow of electricity. If you move, it is in this direction, no electricity will flow. When no electricity flows in the external circuit, the internal circuit shows a potential difference of 1.1 volt. Now, gradually, I start allowing the flow of electricity through the external circuit. As I increase this one, you'll find this value will start decreasing. The internal circuit will show electricity less than 1.1 volt. Now, when I send an electricity of 1.1 volt in the external circuit, this will reach 0. That is, this cell is not going to produce any electricity. And when it is more than 1.1 volt, it's very strange. This whole electrochemical cell will now behave like a electrolytic cell. That is, all the zinc which were going into solution and copper was depositing here, you'll find it's just ulta. Copper will go to the solution and zinc ion will become zinc and deposited on the surface of the electron. Okay, so let me write the observations. The galvanic cell is connected to an external circuit where the electricity will flow in opposite direction. In opposite direction. Okay. Now observation. Okay, observation. I'll write 1, 2, 3 here. 1. When observe when no electricity flows in the external circuit, the internal circuit will produce a potential of 1.1. Second, when gradually electricity is increased in external circuit, the potential difference in the internal circuit will drop below 1.1 volt. Third, when external circuit reaches a potential of 1.1 volt, the electrochemical cell will stop producing electricity. That is, the internal circuit shows 0.00 volt. Okay, then I'll write the fourth one. No space to write. In your book, they have given individual diagram for this one. Fourth point. When electricity in the external circuit is more than 1.1 volt, the electrochemical cell now behaves as an electrolytic cell. First you write, then I will tell you a very wonderful thing. This happening with you every day, you are doing at home. You charge your mobile. You are using battery in your mobile, in your camera. Okay. So once you find the battery strength is decreasing, then you put it on your charger. Charger is see in the mobile when you have a cell, inside this cell or battery, electrochemical This is an electrochemical cell. By chemical reactions, electricity is being produced by which your mobile is functioning. But in that case, what is happening? In that case, you'll find gradually your anode is undergoing corrosion and the thickness of the cathode is increasing. So by that way, what happens? Gradually your mobile strength decreases. So moment you put to the charger, you'll find, because in our houses we are using alternative current, but in electrolytic or electrochemical cell it produces direct current. So when you put a charger, you'll find a small box type of thing is there. This box is nothing why which it converts the alternative current into direct current. That is, you can say it is a battery. All right. So in that case, what happens? The whatever the voltage is being produced by your mobile cell, that when you connect it to your electrical source, it is more than that of your strength of the battery. In that case, what happens? In that case, you find then this electrochemical cell behaves like an electrolytic cell. All right, what happens in this case? Just you will find excess thing which is deposited in the cathode, it will come into solution, and from there the zinc ion, because they are not using zinc, they are using some other thing, you'll find again the cation will go to the cathode. Sorry, this one will go to the anode, and your now battery will be as fresh like a new battery. So the same technique is being used for in your charging of battery. All right. So with this, I finish it today. See you on Tuesday.
Sure.
Thank you, sir.
Thank you, sir.